Today from my home in Boise, Idaho, located in the Pacific Northwest of the United States. My presentation today discussing dam removal is organized into 4 topics: drivers, trends, guidance documents, and 1 dam removal project example. I've scheduled time at the end for questions and discussion. I've also made this presentation available for distribution through Janus with links embedded to online resources. Of all the drivers for dam removal, the most obvious or publicized reason is environmental conditions and habitat restoration. As you will see in the upcoming slides, many projects are located on the coast of the country with migratory fish. Some of the largest projects, such as Elwha River Restoration in Washington State, focused on restoration of fish populations, salmon and steelhead, and natural processes. In March 2014, a movie named Damnation, produced by Patagonia, was released. It presents a compelling case for dam removal. Public safety is also a driver because dams can pose risks, both to recreationists and downstream populations, if dams are not monitored and maintained. The graphic here shows a person caught in a hydraulic roller. Our firm has helped several municipalities with dam modifications or removals to address risks like these. Many other drivers exist as well, including economics, regulatory drivers, and public opinion. For example, in the United States, the Federal Energy Regulatory Commission regulates utilities and issues hydropower licenses. Many of these licenses are now expiring and up for renewal, prompting discussions about whether removal is an appropriate alternative for consideration. The photo in the upper right is from the Chattahoochee River in Georgia, in the southeast part of the country. We led this project for the U.S. Army Corps of Engineers, which removed 2 dams as part of an ecosystem restoration and economic revitalization project. The project's been so successful that people travel from far away to enjoy the whitewater rafting. This project was featured in a documentary named Chattahoochee Unplugged. The next several slides describe trends and show the distribution of dam removals and increasing number of dam removals, relying primarily on data prepared by a nonprofit organization named American Rivers. Nationwide, more than 1,700 dams have been removed from 1912 through 2019, and 90 dams of all sizes were removed in 2019 alone. The slides present similar data as the previous slide, further emphasizing the focus of dam removals on the West Coast, Upper Midwest, and Northeast. The pattern is driven in large part by endangered fish species along the coasts and near the Great Lakes, and removal of old mill dams in the Northeast. This graphic, prepared by Ryan Belmore and colleagues, shows the total number of dams removed since 1944. The study also found that less than 10% of the dam removals have been scientifically evaluated, underscoring the need for more pre- and post-project monitoring. I'm aware of 5 current dam removal projects marked with red dots, again following the overall pattern of geographic location of drivers. In this case, fish passage and aquatic habitat connectivity. I wanted to share 3 future dam removal project examples to convey the types and scale of projects. Our firm is working alongside a nonprofit organization in Colorado to remove an obsolete diversion dam no longer needed for water supply. In the Midwest, the Cuyahoga River is well known, not necessarily for good reasons. In the 1970s, this river actually caught on fire because of the pollution. Now a collaboration between the federal government, state of Ohio, and city of Akron is moving this project ahead. Our firm is developing a sediment removal plan, including management and disposal of contaminated sediment. The largest upcoming dam removal project in the country includes 4 very large hydropower and water supply dams on the Klamath River along the Oregon and California border. This project has been in litigation and planning for decades, and as shown in the schedule, once the decision was made to remove the dams, at least 5 more years of design and permitting are necessary. The Klamath Renewal website has lots of great information about this project, which is a collaboration between the 2 states, several Native American tribes, the U.S. Bureau of Reclamation, the regional utility and current dam owner, Pacificor, and local irrigators. Many resources are available, and what I'm sharing today is just a small example of some of those I have found most helpful. First, in 2019, American Rivers prepared this document titled Removing Small Dams, a Basic Guide for Project Managers. As you can see from the table of contents, it's a practical, hands-on guide targeted for a lay audience, whether that's a nonprofit, private landowner, or a local municipality. And the steps outlined here are pretty typical steps for most dam removal projects. And I'd like to point out the emphasis on monitoring there in the last chapter of this book, and the importance of considering that right from the beginning of the project. A trade organization, the United States Society on Dams, also in 2015 prepared this guidelines for dam decommissioning projects. This is a several hundred-page document targeted toward a professional and technical audience. It builds upon earlier guidelines, and it's basically an overview of steps to consider when considering dam removal, along with other alternatives such as rehabilitation of a structure. Recently, the U.S. Bureau of Reclamation prepared the Dam Removal Analysis Guidelines for Sediment. I consider this the most current and comprehensive document. It too is several hundred pages long. It was in development for over a decade and is authored and reviewed by agency and industry experts, really the top people in the world from my perspective. It incorporates lessons learned from very large dam removal projects, such as the Elwha Dam and Glines Canyon Dam removals on the Elwha River in Washington State. Especially helpful is a 10-step process they use to discuss the sediment analysis, represented by the flow chart in the middle of the document. The entire document is really based upon a risk approach, and on the right side in the upper corner you can see a graphic that basically tries to look at the probability of sediment volume that's stored in the reservoir relative to the annual sediment load. So if the volume stored in the reservoir is very large relative to the annual sediment load or supply to that reach of the river, then one is looking at a larger risk and needing more attention on how that's going to be handled. Oftentimes, the volume of sediment can be estimated more easily. Obviously, if pre-dam topography is available, bathymetry, that's outstanding. But if not, still that can be approximated. What's often more challenging is the average annual sediment load, unless there's some sort of ongoing measurement. The lower right corner talks about sediment risk, basically, again, aligned to those four categories, and what sort of analysis is appropriate given the level of risk. I've included 2 slides here with additional resources. I'm not going to go through each one individually, but there are some patterns. You can see the dates of these publications underscore the interest and support for dam removal that started in the early 2000s. The early efforts were led by nonprofit policy groups, including the Aspen Institute and the Heinz Center for Science, Economics, and the Environment. The Clearinghouse for Dam Removal, the last bullet, is maintained by the University of California and has more than 950 items in the dam removal collection. These final 3 publications are from peer-reviewed journal articles and provide an assessment of the current challenges and opportunities associated with dam removal. I'd like to close with an example of a recent dam removal project led by Jacobs for the St. Regis Mohawk tribe, a Native American tribe located in upper New York State near the Canadian border. This dam was removed in summer and fall of 2016. In the lower left corner, you can see an image of that dam pre-removal. It's a concrete structure, obviously spanning the full channel width, with the powerhouse on the river right. This picture at the top shows during construction, with the powerhouse on the right bank and the area dewatered so that the structures could be removed. And a close-up view of the structures being removed just mechanically with the excavators. This view facing upstream shows the St. Regis River after removal of Hogansburg Dam. Protection of the state route bridge was critical and required additional scour analysis since the bridge had been constructed for reservoir conditions. Bank stabilization using rock and vegetation was also an important element, as well as repurposing old powerhouse. This project was really an exciting project to be involved with. Tony David, shown in the image below, standing closest to the camera, was our project manager. And Tony and other members of the tribe had a vision for this project, and that's really what helped it come together. This was the first removal of a federally licensed dam led by a Native American tribe. It was the first removal of a hydropower dam in New York State. It reconnected over 555 miles of habitat for Atlantic salmon and eel, and it returned project lands to the St. Regis Mohawk tribe. With that, Jess, I'd be happy to answer any questions or any discussion. Thanks.